Welcome to episode 282 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Doing all right, Rob. How you doing?
Doing okay. Not too much news to share myself. Anything from you?
Well, we've been talking about me publishing a printed version of my book, and that happened yesterday.
Oh, nice.
Yesterday, I think. Yeah, yesterday is when I made it official. So it's available now in all of the major Amazon markets. I didn't go to the secondary markets because then your royalties drop drastically.
Oh, okay.
But Amazon.fr.de.in.co.uk.ca.com, it's all I would say, reach probably 90% of my potential market. And it's C++ Best Practices by Jason Turner. Should be pretty easy to find. If anyone wants it.
Awesome. And now I know you said you were thinking of getting a print copy yourself just to see what the quality and everything looked like. Did you wind up doing that?
I did end up ordering author's proofs of both the color and black and white version. So there's actually two versions that I published. Because I asked my patrons, and they said that they would want color syntax highlighting. And it looks like, to me, like a surprising number of people, like maybe 60% or so, are choosing the color version over the black and white version, even though it costs considerably more. But whatever people want.
Awesome.
I make the same royalty regardless. It's the cost difference in printing color books.
It's all just for the ink. Yeah.
Yeah.
Okay. Very cool. Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got a tweet from Ben. He actually tweeted at us and Zach Lieberman, who we had on the show last week. And he wrote, "I just got done listening to your interview on CppCast. I didn't know that you were the original author of Open Frameworks. 6 years ago, I used it to make a short film for my Radical Cinema Workshop class." And he sent a link to it. So if you're interested in seeing just another example of the type of art you can make using C++ and Open Frameworks, I will put this link in the show notes. And it's this 5-minute long video, and it just does some cool things. It's called F of T.
Yeah, I started following Zach in the Open Frameworks Twitter account since then, and every now and then you just get like a really cool visual in your Twitter feed. It's neat.
Yeah, very cool. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Corentin Jabot.
Hello.
Corentin is a freelance developer and member of the C++ committee where he participates in the Unicode and library evolution working groups. Corentin, welcome back to the show.
Hello. Thanks for having me.
Thanks for coming on.
Yeah. So we have a couple news articles to discuss, and then we'll start talking more about, what's going on in the ISO committee, what you've been up to there lately. Okay?
Yeah, sounds good.
Okay. So first thing we have is a post from the Visual C++ blog, and this is faster C++ iteration builds. And this is, I think, in update 16.7 of Visual Studio 2019. They made some pretty significant improvements with linker time improvements, and this should really improve the what they call the inner loop, build debug, edit, build debug, and some like 2x or more improvements with generating PDB and link times and loading PDBs. So it looks like some really nice changes.
This article is fun for me because on the what we did item number 5.
I noticed that one too. Yeah, going from std sort over qsort was one of the things they did to improve performance of link and PDB loading time.
Yeah, I actually made this an example for it was like why use C++ talk that I gave internally at a company several years ago. And I compared qsort to standard sort, and qsort, it's impossible for it to be as efficient as standard sort because qsort has to push everything through void pointers and function pointers. It can't inline any of it. It can't do any of the optimizations that standard sort can.
Yeah. Anything else you wanted to highlight as interesting, Jason or Corentin?
That was the most interesting thing for me.
Okay.
Yeah.
All right. Next thing we have is this blog post, Ray Tracing in Pure CMake. And I saw a lot of talk about this one on the C++ subreddit. I think someone tweeted it at us too. It's amazing that you can do this, that you can make a ray tracer in CMake. I'm amazed that people choose to try to do these things. I don't really know what else to say. It's crazy.
It's very, very impressive. And I understand that like the author did like that for the challenge, but please don't try to do that. Please don't do that in actual production code, and please, like, the less build system code you have, the better you are generally, so you really don't want to use all of this CMake feature and try just to have like the list of files. Don't make your life complicated. Don't try to be clever with CMake.
I think on a kind of a practical quote unquote note though, is there's a pretty good primer on fixed point math in here. And if you have never done fixed point math, then you can learn some stuff from that. Don't deploy it in your CMake ray tracer, but but depending on what your application use cases are, you might have a use case for fixed point math for some reason.
I noticed when I first read through this that this sample image that they have with the ray tracer was rendered in 7 minutes and 23 seconds, which is a lot of time to make just this little orb in a ray tracer. I'm not really sure how long this would take in a standard C++ implementation of a ray tracer, but I would imagine it would be much faster than 7 minutes.
If you offload to the GPU, you can do much more complicated ray tracing real time these days.
Yeah, right.
Yeah. But the thing is with CMake, everything in CMake is a string, so they're actually doing math on string and doing like conversion over and over again, which that alone is probably like super slow.
Right. Very interesting stuff, though. Okay, and then the last blog post we have is on Shafiq Yamor's blog, and this is Zero a Butterfly, which is a reference to that butterfly meme that has been really popular over the past year. And it's just about how special Zero is in C++, sometimes frustratingly so. I don't know, what did you two think about this article?
There's lots of little details in here.
Yeah.
One of the things I learned recently is that the zero pointer, for a very long time I thought like zero as a pointer would be like the address 0, but that's not actually the case. The compiler will translate 0 as a pointer to whatever the null address for that system is. And for 99% of systems, that address will be 0. But it turns out like in the 80s and 70s, some system had like a weird address as that like base address. And so the compiler will translate that for you automatically. And that's something I didn't know until very recently, which I find interesting.
So if you pass 0, meaning null pointer, on a weird architecture, the compiler might actually pass that function 10.
Yeah. And that's done like during compile time or link time. I'm not sure when it's done, but that's how it works.
Wow.
Yeah, I had no idea. It's interesting.
And just remember, if you're writing your own C or C++ parser, a unitary 0 is an octal 0.
Yeah, that thing still frustrates me.
Okay, here's an aside since I'm currently working on a parser. Should I support the 0 leading integral constant as meaning octal, or should I require like 0 little o, the letter O, as if it were hex or binary?
I mean, I think that's the way it should be. But if you're writing a C++ parser, is it better to just, obey the standards and do what all the other parsers would do?
Not a C++ parser, just something that just has integral literals in it.
Oh, okay.
Yeah, maybe I would like use the letter 0. Like, don't do like C++.
Yeah.
Don't do like C++. All right. Thanks.
Okay. Well, Corentin, let's start talking a little bit about what you've been up to lately. You wrote this long blog post back in September about the standard library and the ISO committee, and how it has relatively scarce time and resources. And I thought it was a very interesting blog post. I definitely didn't find myself arguing with anything you wrote there. But yeah, you want to tell us a little bit more about your thoughts there and how well you think ISO has been handling virtual meetings over the past year?
Yeah, it's like really something that have been on my mind a lot recently. So what happened actually is that like in the early, like near like 2009 and the year after, like around the time of like going native, I remember people in the committee, I wasn't in the committee at the time, but when you look at like conferences and like grill the committee panel or whatever, every single time, every single like video you could find, like committee member would say, write a paper to every single question that you ask them, right? Like they, why is C++ like that? And they would say, write a paper. And that at the time there were like maybe like 50 committee members. And they were like, so it was like not a small committee, but like not a big committee either. And they like, I guess, wanted more people and more participation, and they couldn't get all the work themselves. So they were trying to like get more people. And over the past like few years, they really got what they wanted, right? Like since I am like at the committee, maybe like the number of like participation had like maybe a factor of 3, like 3 times as many people since I've joined like in 2018 or something. And it's like been growing, and like now we are like 200 people participating to committee meeting when like we meet face to face. And at the peak of like the 2020 cycle, when people really want to get like 20 things in 2020, we had like mailing with 200 paper. And like there's like a defined pipeline in the committee, and we have been trying to find solutions to make like things smoother and things like that. But the fact is like there are like more papers than we can deal with. Mm-hmm. Mm-hmm. And so it used to be that the committee could like deal with every single paper that they had and like say yes to everything, because like most like the committee hardly say no to a paper. Maybe if you want to like add like garbage collector to C++, we will tell you to go away. But most of the time,
they're trying to remove the garbage collector.
Yeah, we're trying to remove it. But like most of the time, we like people write good paper, and the committee wants to like have this feature and things like that. But like we're stretching the pipeline a bit thin, and we can't deal with like the committee can't deal with everything that it wants to do. And one of the things that we've been doing is adding the library and evolution incubator group, which are like do pre-review and paper just to make sure they like are at least presentable to move forward. And like there are like ton of study group, and like I think there are like 22 or 23 study group at this point, the last one being the C and C++ liaison study group. But the pipeline is still the same, is that you have all these study group doing things, and then it has to go through library evolution or language evolution, and then to wording. And wording is a very slow pipeline because like it's really hard to do wording, and there is a very small number of people in the committee that are actually able to review wording, right? Like there are maybe 10 people that are able to review library wording properly, and same thing for core. And it's even for like simple proposal, like doing wording for this thing is very slow. And so a few things happened like in the last year. One of them is that we've been like very enthusiastic about C++20, and Library Evolution has approved a lot of design for C++20. And like in Belfast and in Prague, like a lot of last-minute small paper has been approved. But library wording, like we didn't have time to review that wording. And so they didn't make it to 20, and there's like a pipeline of 60 papers that library wordings need to look at. Already, and that's at the start of C++20, right?
Right.
And that was the first thing. And then I think we were already super happy with C++20 and very optimistic and say that we were doing a ton of stuff for C++23. But then realizing that C++23 is actually in a year because like it's early 21 and we need to be like the equivalent of feature freeze in basically a year, right? And so it's like a very short, like we have like less than 2 years to do a version of C++. So it's a very short time. And on top of that, there is a COVID situation which has like slowed things dramatically for everyone. And so if like we really have to find way to prioritize things and decide on priority, which is not something the committee was really doing like 5 years ago. Like they had like time to do everything, but now it's really we have to do something, and like the thing we are not doing get deprioritized, right? So we have to select things, and it's not something that it's something we are still learning to do, right? As committee. So that's basically what's happening right now at the committee, is trying to like find better ways to manage like the amount of work that we can do versus the amount of work that we want to do, because like there is a lot of enthusiasm in the committee, and all of the study group want to like, I'm like the Unicode study group, and I want to do like Unicode things. And people are working on linear algebra, networking, graphics, all of this kind of thing. Like there's also like a massive like numeric TS, and all of these things that we want to do, and our time is like super limited, right?
Right.
So that's basically where the committee is right now, which is like, it's both like a good place of being, because that means like both the committee and C++ and like the community, it's very much like alive and doing things, but at the same time it's like complicated to manage that amount of work, right? So basically where we at.
So you are describing it as kind of a pipeline problem, and you know, I have no membership on the committee, but you know, you talked about how the committee itself expanded so much. I guess is the issue just that all these new members, none of them are capable of going on the wording team? Like, is that kind of one of the main issues?
Yeah, I don't know. Like, it's like there's, even if you're like more people in the wording team, you see like one wording team. So it's like, you have all these study groups, right? Like there are like 22 study groups. None of them are active, but like there are maybe like 10 active study groups. And then there are like 2 design study group and 2 wording study group. And the wording is like the slowest part. And you kind of want to be slow because that's like the step where you want to make sure that everything is doing what it says, and like there are like no bugs that are introduced by anything. So you really want like the best C++ expert that you can in that group, both in terms of like just writing the wording or reviewing the wording, but also make sure that there are like no issue with the design that other group didn't found, right? So it's a bit challenging to scale that group in any form, right? But then the question that I'm starting to ask myself is all of the things that the committee is doing, does that like warrant having like a wording specification and going through that very long, arduous and expensive process of standardization, right? And I think that's like a very interesting question. Like what's, for example, like the point of having a networking library within the standard, and cannot it be like just a package on the side or something you find on GitHub or something like that?
Right. Yeah, so and I definitely picked that up in your blog post that you seem to be of the opinion that some of these libraries like networking that are being standardized maybe don't belong in the standard. I mean, is that a common opinion? Do you think there's a chance that networking is not going to be added, or are you
Uh,
kind of go
so,
ahead?
so so I want to be clear, right? That everything I say is like my opinion.
Sure.
There's like no committee. There's like no committee opinion, right? Like until we take a vote and
Right.
it's end up in the standard. There's like no committee opinion. Like I know like people have complained because like contract didn't make it into 20 and people are like, oh, but you said there would be like contract into 20, but like the fact is like until there is like a published standard, nobody really knows what will be into 20 or 23. So we try to have like priorities and plan, and there's like a bold plan for C++23 that we voted less like before we knew there would be a pandemic, so that plan is like a bit ambitious. But just looking at the amount of work that would need to be done for networking to go through, just in terms of design, knowing that we have like 1 year worth of meeting, we meet basically 1.5 hour a week per group, right? Basically, which is already a lot for some people. And so that basically we have like 60. Just for like library feature, we have like 60, 70 hours before the end of C++23. And that is a very short amount of time for the things that we want to do. And so I personally hope that we don't spend too much time on networking because they're like things that maybe like better use of committee time, knowing that we have like limited amount of time. Right, because like the time we spend on networking, we are not spending it on anything else. So it's also like we have to choose, do we want networking or do we want like 10 other smaller feature? Which is a bit unfair for like people like that who really want networking or people working on networking. But we'll see how that goes.
I'm reminded of the graphics proposal that had strong support for a while, and then a slightly different group of people voted on it, and then it was removed from the standard, right?
It was never in the standard. Like.
Oh, okay.
Right.
But there was like not a plenary vote, but like a vote with the entire committee meeting that said we didn't think that was like a priority for C++ with graphics. But I think people are still like working on it and doing some work there. But it's difficult, right? Because like even if like there's like a study group doing something, it doesn't mean that the rest of the committee will be happy with that design.
Right.
So, which is also like a problem with networking because like there are like a small amount of people working on networking for like a decade, and
right.
it's really hard for these people like they want to get results and like have something for their work, and like it's not clear that the committee will say, okay, we will get this done, right? So you can like spend like 10 years working on paper and the committee will say no, either because it doesn't like the paper or because it doesn't think that the paper is a priority for C++. So, but like the committee as a whole actually voted to prioritize networking. So it's not like the highest priority. The thing we're really trying to focus on is executor. Mm-hmm. And we are really trying to make sure that planned into 20 and spending, basically we spent the last 6 months mostly talking about executor in library evolution. And when executor are done, we probably look at networking. But if we look at networking, we're not looking at something else. So I kind of, like my personal hope is that we put networking aside when we realize that even if we look at it, we won't have time to get it done. So.
You said, spend a decade working on the networking proposal, and there's a very I think for the people who are putting this time in, the very real and understandable chance of like burnout, if you put 10, 11 years of your time in and then the committee says, we're not going to accept this, and you're just like, all right, whatever, I'm out of here.
That's definitely something that happens actually in a lot of the time, right? But like all of this big proposal takes like a very, very long time, and so yeah.
So if you said that you would set aside networking because it's big and there's other priorities, what priorities would you want to focus on for C++ 23?
That's a good question. So of course, like the committee like is very, as I said, like focusing on executor and trying to get things done with some form of coroutine support for the standard library. But also a thing we are also trying to do is actually complement things that we did in C++ 20. So for example, in C++ 20, there is ranges, but if you look at what is in ranges in C++ 20, there is a very limited selection of view compared to what you can find in ranges v3, for example. And so there is a group of people that is trying to get like a few more views, like zip and fold, and this kind of thing in 23. We have spent a few meetings recently doing improvement to stud format. And so, and just trying to complement C++ 20, like could take us like the remaining of the meetings that we have, like adding small feature. And like if you look at like how people use C++, you realize that small features are like more used by most people than like big things like networking. Like a stupid example is like one of the very few things that we voted to put in 23 is a content function for string, which is like a very small proposal, but like it will be used by probably like a lot of people. So it's like, it's not like, and it still like takes committee time to get that through. So it's like total maybe like a few like hours of like to discuss the name and to discuss the wording and to, but it's like super useful to have like this small feature as like quality of life improvement.
Yeah, I needed that function about 5 times on Friday alone, actually.
Yeah. So yeah, and there's like another proposal that is in the queue that is like start with and with for string. I think we have like that for string view, but we don't have that for string. So that kind of small thing that we are trying to get done. And then the thing that I would like personally like see progress on is like there have been like conversation for like as long as I've been like a committee member, and I think it's like decade of conversation about like error management, and we don't really like there are people that will never use exception, and there are like people that think we should use exception for everything, and like it has been like an issue. So I would like to see like progress in that area in some form. Like they're like stud expected that is in a TS that has been in the TS for like a few years, and maybe I would like to see progress on that. It's very unlikely, but this kind of thing, I would like to see progress on a paper that was written by Arthur Dwyer, which is like move in terms of copy in terms of move in terms of copy plus disrupt, something like that. That avoid basically that. Provide something that like realloc for a vector. When you move a vector, you don't have to individually move each element. So it's like a lot more efficient because you can implement your vector move in terms of just one mem copy. And so you get like easily like 30% faster operation when you're trying to do like a pushback on like a vector that doesn't have enough capacity because you can just like mem copy all the elements at once. It's somewhere in like the queue of things the committee has to do, but I think the author like dropped the paper on the floor because they don't think they have like enough implementation and experience. But like it's this kind of things that are not really like that doesn't seem like a big feature, but actually like improve the performance of C++ or like make the C++ like more freestanding, friendly, or like improve like exception, or like this kind of like corners of the language that like the committee agrees that we need to find solution about, but we really don't. One of the things we are really struggling with executor. Like executor is basically a bunch of customization points. And the entire committee seems to agree that there's like an issue with customization point and how we declare them and how we define ADL, stuff like that. But like, it's very difficult to convince someone to actually put work into finding solutions to improve like the issue with ADL and finding ways to like write customization points. And so there's like this proposal, I don't know if you saw a proposal for tag invoke, which is a library feature to make writing customization points easier, but it's very much it's still very much a complicated feature to use. And I would like to see like language feature to do that kind of thing. So, and of course, I think we are trying to make progress on reflection, but as I said, we only have like a year and it's like very unlikely that reflection can make progress in like a year.
So does it ever happen that in library evolution you say, you know what, this is an interesting library feature, but really we think it should be a language feature and push it over to the like language evolution group or whatever?
Yeah, we tried, but it's interesting because like if you look at, I don't know, that was long before my time. It might be like before C++11, I don't remember. But it used to be that there was only one pipeline, right? There was only like language library was like one single room and then there was wording, right? So it used to be just 2 rooms and now it's like 20 rooms, right? But now it's like separated, and I think the fact that these two rooms are separated like influence the design of things that we do. Because for example, people in library might think that it's easier to get like a library feature done than a language feature done. So if library really wants something to be done in 23, they will probably try to do it like as a library feature, rather than to try to convince someone from language to do something in time for library to be able to use it. Like there's like this thing that says that like the output of an organization reflects like the structure of that organization, and to some extent like the fact that library and language evolution are separate is kind of somewhat reflected, even if like the 2 group talk and like people go to the two group and so forth. But for someone that is like used to write library feature, it's not necessarily easy to write a language proposal. Like there's like a much higher standard to write a library proposal. Even like if you want to propose like an implementation, writing an implementation for a language feature is like much harder, right? Because you have like to write, you have to modify a compiler, whether a library feature you can just like act together something in Godbolt in an afternoon, right? So yeah.
And prove that it didn't break existing code, right? If it's a language feature.
Yeah. So I think there was at some point like a paper that was like a list of things that library evolution wanted from language evolution, and one of the things was please fix ADL because it's an issue. But at the same time, like fixing ADL is something that everybody would like to do, but nobody really knows how we would even start tackling that issue. People have been, I think like Herb Sutter has a paper for ADL that has been in the work for like 2 decades at this point.
Yeah. One thing I'm curious about is, you're saying that in library evolution you're spending a lot of time on executors right now. When, executors hopefully does make it in past library evolution, is there a vote to decide, what you focus on afterwards? Because I know you're saying, you prefer to work on some of these smaller features, whereas some other people might prefer to work on networking. How is that sort of thing decided?
So what happened is that there was a paper that was voted on in Prague by the entire committee which is a bold plan for C++23. And in that paper, it says that we will make progress on executor, networking, coroutine, standard library module, and we'll try to make progress on reflection. And so because the committee approves that paper in plenary is somewhat binding, so unless someone else managed to get the committee to work on changing the priority, we will keep this priority working like until C++23 ships. But at the same time, we also try to like, in between like the big executor discussion, we try to like work on smaller paper. And like the other thing is like library and core are currently doing, so they have to do wording, but they also have to do issue processing. And because we shipped C++20 recently, and every implementer is currently like trying to like implement C++20, a lot of issues are like made by like implementers. So a lot of time is also spent on fixing issues, and sometimes it has to go back to evolution. How do we want to fix that issue? So because C++20 was a very large release, right? So but yes, the binding plan for the committee is to make progress on networking. We can't like vote on like shipping networking in 23 because like it's not ready until it's ready, right? But we voted to make progress on it. I'm not happy with that, but that's actually the opinion of the committee by a binding vote that networking should be worked on. Yeah.
I also wanted to ask about this paper you wrote. What do we want from a modularized standard library? It's something I think we've talked about on the show before, how, yes, we have modules now, but how much use can we get out of modules when the standard library isn't modularized? But you seem to think that we aren't going to get that much out of modularizing it. Is that right?
So, like there are like two. How do I start? Like there are like two different kind of basically module that we added for like compatibility with older standard. So one is the like module that people talk about mostly, which is like you have your module and you export what you want, and you compile it as a module and you can import it with the import module name syntax, right? Mm-hmm. One was like the other form of module, and with that you are like partition and all of these things that are like related to module, right? Like interface partition, implementation partition, private partition, all of these things. Sorry, not partition, but like module interface, module implementation, and module partitions. But the simpler kind of module is just take an header and basically do the equivalent of a pre-compilation, pre-compile header, right? And so you can actually import header in C++20, and if that header has been like pre-compiled, it will be like imported, like it will be like a pre-compiled header with all the, you don't get like the same like symbol isolation of like not seeing what's not been exported, but you get like the same compilation speed because it has been like pre-compiled and the compiler doesn't have to do the parsing over and over again. And so if your concern is using module for compilation speed, which I think is like what most people want, you can use this module header unit. And if the compiler supports that, in C++20 we explicitly say that every single standard header can be imported. Mm-hmm. So what you can do is precompile all your standard header, and then when you you can like type import angle bracket a vector, it will use like this kind of precompiled header unit kind of module, right? Mm-hmm. And that's one thing you can do. And then we go even further, is that if the compiler knows that vector is an importable header unit, it can replace every single like include vector by import vector and import the precompiled header unit instead. Oh, and so if you have like a compatible C++20, you don't need C++23, right? So in C++20, if your compiler and your build system let you do that, your standard library will always be very fast to include. And then I try to do like some benchmark with like the compiler output, like with Clang, and it's really, really fast, right? Like you can like import the entire standard library, like all the header of the standard library in like a tenth of a second. And so you get like most of the benefits of compilation speed for module that way. And on the other side, all of the other benefits you get from module in terms of symbol isolation and things like that, it is not clear that you can get that from the standard library, notably because of ABI concern. So the standard library implementer will not necessarily want to have like the entire standard library in a module directly. So they will probably like keep the standard library as it is today, and the standard library module will just be re-exporting everything. So the only thing that it would change basically is the syntax of how you import a standard library feature, and behind the scene, like it would behave like if you use the module, but it was actually just like transitively like import an header. So there are like not a lot of benefit from doing that in my point of view. Mm. And the other thing is that we don't like. I think module is one of these features that we understand how it works, like from just like the design of the feature, but it will take like maybe a decade for the C++ community to understand what's the best practice of using module. Mm-hmm. And one of the things we really don't know in the community, and it's like actually really hard to like get data on that, is what's a good size for a module. Like one of the things we talk about is like making a huge stud module, right? And put everything in it. Mm-hmm. And would that be actually reasonably fast to compile or not? And we don't really know. Some people want like really small module, which for me like make no sense whatsoever in terms of like compile speed. Or do we want to have like modules that are like the same size as a standard header currently? Things like that, right? So I think we don't have enough information of like actually being able to like really inform the design of what we want for module in the standard library. And we also I don't feel that it's something that you actually need to use module in C++20. And my personal like expectation is that people will start to use module. So first off, there need to be like build system support, which might take like a few years. Right. And then I think people will start to use module in earnest in new projects. And for legacy code, they will keep using this importable header unit transparently. And like header unit was really designed for, like it was a design goal of people originally to not have to rewrite all their code for module. So that's why we're like this kind of like two different model for legacy support. So for new project, like use module, and you don't need like standard library support to do that at all. And if you want like better compile speed out of your like standard header, please ask your implementer to support that feature, and your build system maintainer to support that feature.
Yeah, I will say I don't remember who it was we had on recently, Rob, who said they thought it would be that modules is basically a C++23 feature because that's when we'll actually be using modules. Mm-hmm. Corentin, you're more pessimistic than they are, saying, what'd you say, a decade or so before we really know how modules should be used?
It's like but I feel like we are still like having debate about like how to use auto in C++, right? So it's not that people will start using module in a decade. Like they will start using it like maybe 3 years is a reasonable assumption, but then it takes a long time to actually like you have to deploy module for like a few years and basically look at what went right and wrong before you start to understand really the best practice of that feature. So like we understand how module work, but we don't know what the best practice for module are. And that like takes, basically what it takes is like very large team deploying module in very large project and see what kind of benefits they get from that, how they can teach module, how they can deploy module, how they kind of benefits they get from using module at large scale, what's the impact with in regard to distributed build system, because that was like a huge point of contention, and we really don't know what the performance of module are within a distributed build system. So all of this kind of question is something that you actually need to use the feature for a long time before say, okay, we should like use modules that are like this number of classes or this number of symbol of this size and things like that.
Right.
But yeah, I think like 3 years is like maybe a good assumption. Maybe that's like optimistic, I don't know. Depends on how fast people can like update their build system once build system supports that. I don't think like no one will use module until CMake has very good module support. Mm-hmm. And then when CMake start to have like module support, it will people will start to use them in new projects.
That's probably a good point, yeah. Yeah. That build system we all love to hate and use anyhow, and yeah.
Yeah.
Make ray tracers out of.
Yeah. Yeah, right.
You mentioned earlier that there was this binding paper about the direction of C++ 23 that was, talked about the direction of focusing on executors and networking. If you were to write your own version of that paper, what would you set the direction of C++ 23 as? What do you think would be the most important features to focus on?
So I still don't know if I like the idea of like giving priorities. Like it's really hard for like the committee to give priorities to begin with, because everything the committee does on a volunteer basis, right? Like nobody is paid to do committee work, or they might be paid like by their company to attend meeting or whatever, but like the committee itself cannot give anyone, the committee cannot say we will do that, because like then you have to ask someone to do it, and that someone will like want to be paid or whatever. So the committee cannot like give order to anyone, right? So priority, like the priorities that are in that plan are there because they're like paper for this feature already. So the priority is really saying we are looking at that paper that someone already committed they wanted to work on. Mm-hmm. And for example, that's why like hunches are not mentioned in that paper, because at the time that paper was written, there were like no paper to say we want to do that for hunches in C++ 23. And so for me, I don't know if like trying to have these priorities like really works like really well in like the way the committee is working on like being this on a volunteer basis and working as what is ready and whatnot. But like in terms of like the absolute priority, but I think like the entire committee agree with that, is like reflection. Not only because like reflection is useful on its own for people, and people have been asking for reflection for very long, but also once you get like reflection, you can like write like a lot of papers that are like proposed, either like library feature or language feature, whatever, can be implemented on top of reflection or with reflection. And so once you have reflection, you can like remove a lot of language feature proposal, because you can do the same thing with reflection. So I think that like a very big priority for C++, but at the same time, it's a very large chunk of work. And there was recently, I think you talked about it in the show last year, this paper from Andre Sutton, which is meta-reflection for meta reflection for C++, something like that, which is a 26 pages paper that lay a plan for reflection, and that's like 6 or more years of work. And we don't yet know if we can like find a subset of that work for 23 in the amount of time that evolution has. And I think like by the time we get like executor done in library, like the C++ 23 at that point will basically like be near completion. Like we will be done with that like probably like this summer, and then it's like not that much time to do actually a ton of work. So and it's like super, like it's super annoying, right? Because at some point in like June last year, I think I couldn't like focus on anything else, so I wrote like 10 papers because that's what I do, and it's like it's all things that I think would be like useful to have in C++, and like I think they're like good features. That's why I propose them, right? But then you start to think, okay, my work is actually like more priority than everything else we have on our plate, and it's not, right? So a lot of the things I'm working on will certainly not make it into 23 because like it's not priority, right?
Right.
And I think like a lot of people are in this situation where like they have like very good idea for C++, but we just simply don't have time to look at that in the time that we have, which is, yeah, it's what it is. Right. But like for things like networking, you can use ASIO today, and that's like what I'm trying to explain to people, right? ASIO is a superset of the networking TS that you can use today, and it's header only, so it takes like 5 minutes to add to your build system. So if we don't have networking in C++ 23, you are really not missing anything.
Right, and if you're using Conan or something already, then you can pretty much just type a few buttons and you have ASIO ready to go.
Yeah, exactly, right. And like there are like two versions. Like you talk about like networking recently with Robert, I think. And like as you said, like there are like a version of Azure that depend on boots, but there's also a stand-alone version of Azure, which is header only, and so. And yeah, and the other thing I haven't mentioned is that I have like a feeling that implementer, like once the feature is in the standard is just the beginning, right? It has to be implemented in like 3 compiler, and C++ 20 was a big chunk of work for implementer, and it will be like quite a long time before like all 3 or 4 major implementation of C++ 23 conformance. And so asking these people to on top of that like implement networking, it's a bit much.
Yeah.
They're like implementations that still don't implement C++ 17, right?
Yes.
Yeah.
Because like it took like the committee a fairly short amount of time to say we want a function that converts a string to a double without string exception. That like you can do that in like 1 hour, and like 4 years later, people are still trying to find ways to implement that.
That's to cars and from cars or whatever, right?
Right.
Which I think Visual Studios might be the only one with an implementation still.
I think so.
Maybe
and it took like Stefan Lafarge like 2 years to do that, basically.
He called it his final boss, I believe, in a Twitter thread.
Yeah. I think it did like a very great CppCon talk last year to explain why it was so complicated. The other very big feature that has not really been implemented everywhere except in Microsoft is the parallel algorithm. And then again, that like a feature that is very easy for like the committee to do, like relatively speaking. Like
right.
It's not like a huge amount of work for the committee to do that. Although we had to make sure that it was actually implementable, but then actually doing that work has taken like a very long time to Microsoft. And I think GCC and libc++ are still struggling to get that done. And I know that like Intel had to give like GCC and Clang like the permission to use like the parallel standard libraries that they had and things like that. And
yeah, GCC has, just for the record, officially adopted Intel's implementation.
Okay.
Yeah. Okay.
So you have it with GCC, and you have to link with -LTBB to actually get it to work.
Oh yeah, so they don't ship the library itself. You have to, yeah. So,
Okay.
yeah. So
Well,
like,
interesting point.
Go ahead.
Yeah. So given like the amount of work that it takes to add something to the standard, like we have to ask, is it really necessary to have that thing in the standard, right? Which is like very different from what we did before, which was, is that useful, right? And like the answer to is that useful is basically universally yes.
Right.
Everything is useful to someone, but it's like it's no longer sufficient to get something in C++. And we have like to spend a lot amount of time like doing prioritization, which we didn't do before. So we have like a list of paper in flight, and we like to say, okay, do we want like having like a string content function, but like do we want it more than having like optional monadic or things like that? So it's really difficult. It's a really difficult thing to do, especially for paper author when they find that their paper is like in the bottom of the backlog, which might as well mean that we might like look at them in like a few years. It's
Okay. Well, yeah, makes sense. It was great having you on the show again, Corentin. Is there anything else you want to plug or go over before we let you go?
No, I think that's it. It was really great talking to you guys.
Yeah, it's great having you on again.
Awesome. Thanks.
Yes.